Welcome to the coldest room in all of London, and welcome to my talk as well. Today I want to talk about on-call, and more specifically about alerting inside on-call. I'm curious to hear from you. Who of you is or has been part of an on-call rotation? Can I get some hands? Okay, who of you is on-call right now? There is. If you get an incident, come here. We'll fix it together. So the thesis of this talk is that bad alerting can add a lot of friction, can make something that is already certainly might be a bit difficult, can make it worse. But we can do better. That's the message of this talk. I want to talk about concrete dysfunctions, that's how I call them, that I've seen all over my time operating production software, and what to do about them so that you have some actual tangible things that you can do in case you want to improve things, not just talk about what doesn't work. Given how many hands were raised, I don't think I need to talk a lot about on-call, so I'm going to fly over this. For me, on-call is not about action, it's about reaction. It's about being available. When you get called, like the shirt there in the back, when you get called, you can jump in. You are not checking constantly like a dashboard, right, the whole day. And this happens as part of the rotation. Sadly enough, I know some people that have done on-call in their companies or in their teams or in their organizations alone, and I find that something that it's hard to comprehend, but it is something that you do as a team, right? There's a certain rotation, you are swapping it, can be a week like here, can be more often, maybe longer, and can be business hours, can be 24/7. But it's a rotation in any case. And I think one question that one might ask themselves, we might ask ourselves is, why actually are we going to do all this? Why do we go through this? And it's about expectations. Users nowadays, they really expect your website, your application to work instantly. If I pull my phone, I want to order something and it doesn't work, I go to the next one, right? That's expectations of the user demand that things are available at all times. This has been driven by big tech mostly, right? I think Google, Netflix, or Facebook have set the expectations, although, to be fair, Facebook hasn't done the best job lately of keeping those expectations, right? And that just goes to show that this stuff is not easy. This is a hard thing to do. And a second reason is, I would call it like you build it, you run it, as started by Amazon, I believe, where application teams take on more responsibility, operational responsibility for their apps. They are more responsible to keep them up. And that is, I say, it's skinning the game in a sense, right? Like the developers of an application are encouraged to build it in a way that is more resilient and it's going to give less issues. And also it makes it easier in a sense because there are fewer handovers, so you don't really need to pass it to an operations team, which might be very hard to do in case you have a complex, say you're doing microservices, every team is doing things slightly differently. It might be really hard for an operations team to take ownership of all that. So the idea of you build, you run it is you kind of bring it back so that there's a bit more collaboration, right? And you can, those two reasons are the ones that came up. You can be more or less happy with them, but I think on-call and operating production software at all times is a reality, and it's getting more and more prevalent. The only exception I could think of is I don't know, if at least in Spain, if you want to pay your taxes, you have to do it during business hours because the transfer will fail otherwise. But I don't think everybody can afford to do that, except if you are a government. And even then, I think the UK government is really tech-savvy, so expectations are there. So then it comes alerting. On-call is a very big topic, and it's a topic that you can do a conference about. So I cannot really, in 40 minutes, cover everything. So I just want to focus on the alerting part. And before that, I just want to go over what I mean when I talk about alerting. To put it bluntly, or as simple as possible, is you want to detect problems in production before your customers do. And I had another one, like use these emails when some top management figures out that something is not working, and then it goes to the next one and next one down to the person who was supposed to observe the systems. You really want those emails to go up, not downwards, right? That's also an encouragement to do alerting and to figure out things before your management does. Although maybe shouldn't happen, right? And alerting is a combination of monitoring and notification. Monitoring is about observability, about extracting signals out of a system so that we know the state in which that system is. Those signals, we want to do something with them. We want to, based on certain thresholds, based on certain conditions, we want to notify the right person, and that's where the notification part comes. So we want to reach the right person that is capable of handling that monitoring alert. So it's these two things. And if you have read the SRE book, there are many ways of monitoring. It's another topic on its own. And what they call the 4 golden signals are latency, traffic, errors, and saturation, which cover most of it. Latency, right, how fast a website responds to an answer, to a request. Traffic is the amount of actual traffic there is. Errors is how many of these requests are actually failing. And saturation is like how overloaded the system is. So based on this, you can really cover most of it. And as I talked about friction a few minutes ago, and you have been, I saw a lot of people that have been on call. On call can suck. It can suck in many different ways, but I want to talk about the alerting part of it. And it can be really something that is, like a source of friction in your life. So let's go over some examples. One is constant interruptions. You see there, I happen to be interrupted quite a bit in that rotation, and that can take you out of your day-to-day, right? Like if you are trying to, at least in the teams I've been on, when you are in a rotation, you are actually still working on your day-to-day. So if you're getting constantly interrupted, you kind of lose your flow, and it can really be disruptive for your day-to-day work. And that's actually that's a good case, because that means that you're getting interrupted during business hours. What happens if you start getting called by some random numbers at night? That is okay if it happens once, but what if you have a rotation where you are getting this multiple days in a row? Then it's when your quality of life starts decreasing very sharply, and it can really lead to burnout very quickly. So it's something that you cannot really do for a long time. And these alerts, it's doubly frustrating when they're actually things that don't really matter. So if you see this alert, if you see the timestamps, if they're readable, this thing triggered at 8:31 and resolved itself at 8:33, which means that if I had been waking up for this, by the time I get to my computer and I open it, it's already resolved. So not only I'm getting disrupted, but it's for nothing. I could go on and on, but I think you get the point. Alerting is a potential cause of developers being grumpy, and nobody wants that. So that's what I want to talk about today. I want to talk about alerting dysfunctions, and I want to talk, I have 5 of them, 5 dysfunctions of a team. And this is a summary of a couple of experiences. I've been, I think, on call for the past 2 years, at least, in different organizations, and before that, also operating things that are, with production responsibility, so to say. And I've seen patterns, and they tend to repeat themselves. So I would say, well, maybe this is something that's unique to a certain set, but actually, I tend to see the same things happening over and over. So that's the ones I want to talk about. There are these 5. I'm going to go over each of those, talk about, what is that, how does it happen, and have a learning in the end, what is something that can be done, something actionable. So that is not just about, recognizing what's wrong, but also about how to change it. So let me get started. I want to start with mixed abstraction levels. And that might not make sense yet, but I hope it will do in a second. It will do in a second. So it comes down to the question of what are you monitoring? When you are observing a system, what are you trying to see? And there are many different types of monitoring, so you can actually really do a lot. So you have things that are more high level, right? When you are monitoring something that from the perspective of the user, like how a user is interacting with an application. And there are other signals that are lower level, where you are getting closer all the way down to the infrastructure. Maybe you want to see how a particular server is behaving, or even a process. And like this high level and low level, for me, lends itself to think in terms of a pyramid. Like you're familiar with the testing pyramid. It's, like you have at the bottom things that are low level, like unit tests, and then you build on top of that. There are tests like integration tests, perhaps, then maybe like things like very high level, like end-to-end or acceptance tests. And each has a purpose. It's not like one is more important than the other, but you really have to consider where they fit. And I think monitoring, for me, it feels natural to think about that. But honestly, I didn't really find a lot about monitoring pyramids when I was looking at it, so I'll keep going with it anyways. So we will try to fill this pyramid. There are way more ways, way more monitoring tools than this, but I just wanted to give you an idea, right? At the bottom, we have something like infrastructure monitoring, very low level, like something where, individual pieces. And then you build on top of it. You have something like APM, where you are monitoring a single application. And then you continue going up, where you start seeing the application from the perspective of a user, all the way to synthetic monitoring, which I'll get to that in a second, in case you're not familiar with that. And so the important part here is that you should use the right, when you're writing code, right, like a typical no-go is to monitor something very simple with a very high-level end-to-end test that takes long to run, is like very broad, and it's hard to figure out what's, maybe even flaky. It's hard to figure out what you are looking for, right? And so that's the learning. And I have some examples. This is a synthetic test. And in case you don't know what synthetic monitor, synthetic transaction, synthetic test, I think it has a few names. It's basically an end-to-end test. I'm running a series of steps from like simulating the actions of a user and performing a certain flow. It can be browser-based, or it can be API-based. It can even be DNS-based, for instance. And you run this, and it's much like similar to an end-to-end test, but it's something that you're running continuously. You're running it continuously from different locations, so you get a constant stream of feedback of, can my user perform certain actions, like logging or checkout, like certain core flows. So it's a very high level, and it answers a very concrete question about, are my user able to interact with the site in a certain way? If we move all the way down to the other end of the spectrum, we have something like an infrastructure test, where this is just monitoring the CPU usage of a certain server over time. This says nothing about how a user is, I cannot really draw conclusions about what users are doing with my site based on this, but I can understand like the single pieces. If I'm trying to understand, if I have this thing pointing at a database server, and I keep getting CPU load of 95% over a period of time, I can probably infer that something might go wrong with that server at some point. And that's the thing, right? Like, if you think in terms of a pyramid, you have to choose the right alert for the right situation. Coming back to the on-call part, I personally, when I get paged, one thing I really want to know is, what's the user impact of this? Because based on that assessment, the next steps follow very naturally, right? If I'm being paged and I can verify that users cannot use my site or the application I'm responsible for, I really need to think about communication. I really need to think about who needs to know, who needs to be involved, like what are the next actions, what is the checklist. Whereas if I get a page and it's like, yeah, this CPU stuff is elevated, but we cannot confirm any impact, I might be able to say, I can think of that a bit later. I don't need to do it in the middle of the night. And that reflects in dashboards. Everybody has a ton of dashboards, right, today? And I think one common pattern is to put everything you have there, right? This typical Grafana dashboard with 50, 60 widgets, which says everything about everything you might want to know about your application or whole system. And at the same time, it says nothing, because there is so much stuff there that you cannot really know. Like just understanding that is a job on its own. So I really encourage when in the teams we do we take operational responsibility to think of, do we have a place where we can say, are the users impacted? And this is a really important thing, especially when you are reacting to an alert, when you really need to make a decision, right? So the first learning is use the right alert for the right job. So think in terms of monitoring pyramid, if that helps. Second one is the lack of automation. Getting used to do things by hand. Manual work is not reproducible. I mean, have you checked AWS has a lot of documentation regarding, like how to set up things. And somehow, it often is based on manual, going through the UI and clicking on 100,000 pages and doing that. And you see that the tutorials from AWS are super comprehensive. And yet, they are super hard as well. They must be really hard to maintain and write, because that's really, for me, hard to transmit that information, where a piece of code could do the exact same thing in a way that is executable. So my claim is that automation is fundamental in alerting. And I think infrastructure as code is not really something that is very controversial these days anymore. So we have accepted, right, in the industry, that infrastructure is something that you can manage much more easily if you use code, if you use automated processes to provision code. Well, infrastructure, monitoring, alerting, all that is part of infrastructure. It's not a Kubernetes cluster, but it's still part of your infrastructure. So for me, it follows that you should also automate that. And I see there are many benefits, but I want to talk about two in particular. One is maintenance. If you have a complex setup, you will have a complex set of monitoring on top of it, and that gets hard to maintain. A pretty notorious example in my experience are runbooks. Keeping the runbooks up to date is a pretty heroic effort if you do it by hand. But if you have it automated in some way, it's a lot less effort. And there's always this tension between feature work and infrastructure, right, and maintaining things and building new things. If you reduce the amount of effort that it takes, the conversation gets a lot easier. The second one is spreading best practices. Let's say, through trial and error, you build a set of alerts that really give a really strong signal for a service, and then for the next service that you write, you start from scratch, that's what happens if you don't really have any automation, right? So then you relearn all the lessons from zero. So that doesn't make any sense to me, so that's why I think automation is core. I particularly like Terraform a lot, but it's not about concrete tools. There are many alternatives, and honestly, you can even write a bash script if that really helps. That's enough. But I like Terraform, and I want to show some examples. This is how to provision a Datadog monitor, and it's a bit simplified so that it fits in the slide, so the code would probably go to the ceiling, a bit more. And it's a building block that you can reuse, right? You parameterize so that you can kind of use this with the values that make sense for you. The same, as I said, alerts also have a notification component. So if you're using something like PagerDuty, you can also configure things like schedules, service topologies. Many other things can be configured, and Terraform and other tools there is a lot of tooling out there. And this is good, right? These are building blocks, right? This is simple. Maybe this on its own is not super valuable, but the thing with building blocks is that you reuse them. And so I want to, think of more complex example. I don't know if you're familiar with multi-window, multi-vulnerability alerts. It's a thing that comes out of the SRE handbook, and it's probably a talk on its own to go in detail over that. But the TLDR is that it's a relatively complex alert. And I have here a chart, and the idea behind these alerts is that you have different burn rates. Like you measure the speed at which you consume your error budget, so it's tied to an SLO, and you measure that at different speeds, right? So those are the 3 blue lines. But then, to make them more reliable, you have different windows for each burn rate. So you have 2 of them. And so this is a lot of, I mean, at the end, what I'm saying is one of these alerts ends up being like 6 different alerts that you kind of combine. And I can tell you this is close to impossible to do by hand. Might be, but I think you go mad if you try to do this too often. And so that's where our building blocks come in. The building blocks we had before, we can build on top of them. We take this monitor, and we build observing an error ratio here. It's for a Java service, but it also works for other, so it's configurable. So you have this base block. And then you build, again, something else on top. You put the burn rate on top of this with some thresholds, like the burn rate, the window, and whatnot. All this, again, can be done by hand, but there are so many numbers there that it's very easy to make mistakes. So you have this, and then you keep iterating up until building the whole thing, like the block there. That would be a collection of a couple of different alerts with its own nicely formatted runbook, and you end up building something that is relatively complex in my view, and this is maintainable. I mean, it's fair to say that this example is heavily simplified. I think the whole thing is built recently. A couple hundred lines of Terraform, all in all. So it's not like you are, I mean, definitely not something that is simple, but it's possible. And my claim is that this is not possible to do by hand, unless you have superhuman discipline to keep tuning this and not forget the single spot that will break the whole thing. So it's about scaling. You scale inside your team so that you are consistent about monitoring. You shouldn't be defining different monitoring, different ways of monitoring or alerting for different services, right? You should do it once and kind of apply it consistently. And you scale it across teams, because not every team moves at the same speed. Some are maybe further in the journey, some are maybe a bit behind. And that doesn't mean that everybody has to relearn the same lessons from scratch, right? So that's the key. So the second learning is use automation. If you're using it, use more of it. I don't know if you can use too much automation. Maybe you can. But I think it's hard to reach. And if they are going to take one thing out of this talk, I would probably pick this one. There is a lot of room for automation. So we spoke about the levels of abstractions and automation. Now I want to talk about noise. You know, alerting we want a lot of signal, and we don't want to be drowned in noise. And the big risk that you have when you have too much noise is fatigue. I mean, it's totally natural, right? Imagine that imagine that your phone is ringing constantly because you're being paged for things, and 80% of them are not meaningful or don't have enough information. What do? Over time, you start tuning out. It's totally natural, right? Alerting is something that is about tension in a sense. It could be that the time that your phone rings, your whole site is down and you are having a significant problem, but you cannot live in that state continuously. If you do that, the natural reaction to that is to ignore it. And that's something, once you start ignoring alerts, then it's lost, because you will definitely, sooner or later, ignore the one that is super important. And the frustrating part about noise is that a lot of it is accidental. I mean, any system has a certain amount of inherent complexity to it. You cannot avoid that. But we somehow, at least where I've been, we somehow managed to add a noise on top of it that seems to me a bit for free. I have some examples, and these alerts there's not a lot of context to it, so it's okay, maybe it won't make as much sense as it should, but I just want to focus on some key aspects. This alert is one that we actually have we had in my project, and we were essentially monitoring that Kubernetes was restarting pods. It came down to that. And then you start thinking, I mean, isn't Kubernetes, the whole point of Kubernetes restarting pods? You have auto-scaling, you have quotas, you have nodes that go up and down. Like, that's pretty much the reason why we don't do it by ourselves, and we leave it for Kubernetes. So if I'm trying to monitor that Kubernetes is doing its job and actually triggering warning alerts for that, I don't really know what I'm trying to do, but it doesn't seem to make a lot of sense to me. And yet, you can find this in the wild. Sadly, I didn't make this up. This one, I'm even less context here. This is an alert, and you are saying, all right, I have no idea what this is. But the problem is that I also don't have any idea what this is. This thing, I found this in a triggering in a Slack channel, and I couldn't find anybody to explain to me what the purpose of this was. And so I think warnings are evil. Like in linters, in alerts, I really like, like binary decisions. Either something is important enough that I need to take an action, so it's a proper alert, or is it not important enough, and then I ignore it. But I don't like this in the middle of, we don't want to commit to it, so let's put a warning, and somebody will look at it, which won't be for long. And this is another personal favorite of mine. This is a real quote, and it's from a project I joined some time ago as a tech lead, and they already were doing operating a bunch of infrastructure, and they were doing on-call. And one of the developers told me once that, yeah, this alert, when it triggers, I just turn around and continue sleeping. And I don't know. I was flabbergasted because, like, how can something, how can you get to a point where that feels normal, where you can be called at 4 in the morning, and it's like, yeah, well, it happens, it's just life. I cannot believe we can get to that, and I think that's something that has to be rejected from the get-go. Like, you can never get to that point. And again, another alert without context, just focus on the timeline for this one, because that's the interesting part here. This is another alert that I found in a project, and this one had the nice, you see there, mid-July was the first occurrence, like the spikes are when they would trigger. We have August, and we have something end of September. So we have a period of 3-4 months where this thing was triggering, and nobody managed to fix it, because you see it here. And that is, accepting the status quo, which is, it's more organizational. Right? It doesn't have to do anything with technology or tools. It's more like getting used to things, and I don't think we should get used to these things. So delete them. I always say that delete all this crap. If it's needed, surely somebody will find it important and will recreate it. And that's the point, right? If you have invested in automation, deleting things is very cheap, because you can always recreate it. If you're afraid that if you delete it, you won't be able to recreate it, that's not a reason not to delete it. That's a reason to invest in the process of being able to recreate it, right? So the third learning is noise is really poisonous and has to be reduced at all costs. I feel like I'm pointing the obvious here, and yet I can tell you it's a pattern that I see in almost every project I join. So, in time? Okay. For the fourth one, I want to talk a bit about tools. And tools, for me, the purpose of tools, especially in automation, is making our life easier. And I'm going to quote myself for this one. And I really find that crappy tools are extra crappy when you have to use them at 3 in the morning. And so, as I said, tooling in alerting is a mixture of monitoring and notification. So the space is it's booming with really high-quality tools. And the point of this is not use tool X, it's use a tool that is helping you. My examples are based on Datadog and PagerDuty, because honestly, it's what I'm using right now, and it was easier to get screenshots. But it's definitely not the only alternative. And I want to ask you, do you take these tools for granted? And it's a bit of a rhetorical question, because I've learned that at least you cannot always take them for granted. I was in a project for a German client, all like very known German company, and they were moving vast majority of their infrastructure to the cloud, but for some reason, they were attached to their old ticketing system, and we had to send the alerts to it. Don't ask me why. And that thing was a project out of the 90s that, I mean, should have never existed in the first place, I would say. And it had like a lot of features that you assume are basic for, and I mean, if you use, I don't know, PagerDuty, Opsgenie, anything, a lot of these features were not there. Things like auto-closing, things like auto-grouping, conditional routing. So it didn't have any of that. So what happened was we had like some Kubernetes clusters, and they might have there might be a problem, like a node will go down, and then we had a lot of alerts. We were working with Prometheus, so we had a very comprehensive setup. So all these alerts would start to trigger. But given that the tool didn't really group them, didn't really close them, we had a first-level support team, which is another talk on its own, and they would wake up and they would find 150 emails, because this tool did emails. They didn't do any other notification. So they had 150 emails there, and 147 of them were actually closed by the time, didn't exist anymore by the time they checked them. But there was no way of doing this other than going through the emails manually, one by one. And so I think that, there are a lot of things to say there, but I think it can be summarized in use the right tool. There are very good tools, and sometimes you have to pay for them, but that's the way it should be, right? You cannot forget that when teams start taking on-call duties, they're making a pretty significant commitment. I don't know about you, but I kind of like sleeping. It's one thing I like. And also I like, if you take this stuff seriously, if you are on call, are you actually going to go to a restaurant, maybe have a glass of wine too much, and then say, oh, they are calling me, and now I'm not sure if I'm in a condition of respond to this? So depending on the system, depending on how many people and so on, it's something that you take seriously. So if you expect professionalism from your developers, you should give them professional tools. And I hope I wouldn't have to have this slide here, but honestly, my experience is that it's not always something that you can assume. And so for the next dysfunction, I want to talk about tuning. Tuning alerts is hard. That has been my experience. And it's hard because you are doing two things at the same time. When you are trying to configure an alarm, you want to do two things. You want to minimize false positives and minimize false negatives. So false positives meaning that if an alert triggers, it should be because there's a serious issue. And false negatives means that if an alert triggers, that issues should actually trigger alerts. And these two things are a bit conflicting with each other, right? An excellent way of minimizing a false positive is to delete all your alerts, right? You will never get a false positive if you don't do alerts. But that kind of goes against the other point. So you have to find this balance in the middle. And this is it's always something like flimsy, and it's always very dynamic because it evolves all the time. And so I have some thoughts here. I would encourage using ratios. And what do I mean by that? This is an alert that measures errors, but it has an absolute number. So it will trigger if the number of errors that we collect in the client side is higher than 20. And why 20? And what does mean 20? Is 20 a lot? Is 20 out of how many requests? It doesn't have any context. So it's essentially untunable by design because that is not something you can really adapt. So it's much better to say, if I tell you 20 errors, you say, I have no idea what you're talking about. But if I say our system is 50% of the requests from our system are failing, you would say, that's not the most resilient system I've ever heard of. And the ratio brings a lot of context, which is something that you really need. Data. In the end, monitoring, to a certain extent, is a bit about numbers, right? About compiling enough signals so that the outliers get even out. In this example, a service with low traffic is really, really hard to tune. This one, I don't know if it's 1,000 requests a day or an hour. But one way or the other, it's not a lot. That means that a system with low traffic, it just takes a few requests, some outliers, something going slightly wrong, for the whole metric to skew a lot and to create these peaks that are the ones that trigger alerts, and thus things are close to impossible to really get. Again, minimizing false positives and false negatives at the same time, right? So solutions there are not really a lot of solutions for this. But one is synthetic traffic. Like if you can create some sort of synthetic traffic, you can more or less fake it or group them in. Is that an alert? You can group them in like multiple services. So make at the end, get a corpus of data big enough to draw meaningful conclusions out of it. And then it's I like to talk, I like to have a lot of small alerts. By that I mean, let's assume we're talking about error rates. You are trying to understand the error rates in an application, and you are sometimes trying to measure more than one thing at the same time. You want to detect, if the service goes down, the error rate will go to 100%. I want to react to that very quickly. But also there are other type of problems. Maybe there is something that starts going wrong, but not very wrong, like it's an elevated error rate, but not too high, but that lasts for a longer period of time. If I'm trying to create one alert that catches all of this, it's exceedingly hard not to overtune it in one of the directions. Maybe you'll trigger it too soon when it's actually not threatening your SLOs, or the other way around, it's not sensitive enough and you are ignoring a problem. So for me, the solution is to decompose this in smaller pieces. Have alerts focus. That's kind of the idea behind multi-burn rate alerts. Have a lot of smaller alerts that measure very small things that are relatively easy to keep in your head and easy to keep in tune. And this builds on top of everything else, right? If you are considering the abstraction level, if you have the tools to create alerts in an automated way, this is not expensive. If you have the right tool, having a lot of alerts is not really a problem because it gets filtered properly. So if you have all these steps, this is not really an issue. But you shouldn't start with small alerts if you don't have the things before. Reliable alerts are hard, one way or the other. And there's another point I want to make. In the end, alerting is reflects the underlying reality of a system. There are a lot of things that we can do. I've gone through a bunch of different actions that we can take, so there is definitely things we can do to improve. But if a system is fundamentally unreliable, flaky, inconsistent, the alerting is going to reflect that. So at some point, there's a limit of what you can accomplish just by working on alerting, which is the symptom. At some point, you have to treat the cause as well. Having said that, there is a lot of potential in tuning, and you can get a lot of mileage out of it, so it's definitely something to consider. So those were the 5 dysfunctions I wanted to talk about today. And before I finish, I want to show them again and show the actions as a sort of a summary. So I've talked about mixed abstraction levels, about lack of automation, about noisy alerts, about inadequate tools, and about tuning. And I wanted, so side-by-side actions that one can do using the right alert, leverage automation, reduce noise, adopting tools, tune alerts often. As I said, my personal favorite is automation, but this is very context dependent. If you are having issues in your own, team, organization, it really depends. Maybe you have invested already in some areas and some underinvested, so that's something that is a personal call. So they are in this order, but I wouldn't consider that have to be treated in that order necessarily. And this is just a starting point. There is a ton that can be said about alerts, and there are whole books written about it, and this is something that you can get inspired for, so this is starting point in a journey. I didn't introduce myself until now. How rude of me. So my name is Mario. I'm a staff engineer at Wafer, and I hope that my talk has gave you some nuggets in your journey to make your own on-call rotations more bearable. Did you get called during the call? Perfect. Thanks a lot for your attention, and I'll be happy to answer any questions you might have. Yeah.
We are having a lot of shift from right to left initiatives in certain areas. Do you think it makes also sense to set up these kind of alerts already by, or starting to set up and think about these alerts already by the developers?
All right, so the question was whether it makes sense to shift left the alerts and build them early and have the developers take the ownership of that. I totally think that makes sense. And I mean, like, I don't know how early is too early. Like, I guess you definitely, I mean, for me, a service is not in production if there is no monitoring for it, and if you don't really know what's going on. So for me, there should be like something that happens quite early. And maybe if you have the tooling, in the end it's something that maybe you can do it as part of bootstrapping the app, or maybe we can start with same defaults or reusing this Terraform modules or something like that. But I definitely would say, yeah, that has to happen. To put it differently, I probably think it's fair to block a service from being, like, you cannot rely on, if you are starting to rely on a service in production and that thing is not confirmed to work, that shouldn't be allowed, I would say, at some stage, and the earlier the better. Is there a question on the back?
You spoke about the testing pyramid. With there's a hard and fast rule that, like, the lower you go, the more of this you need to do. So more unit tests than end-to-end tests. Is there a similar type of, like, generic rule you can apply to alerts?
I mean, the question is regarding, like, there is the testing pyramid where you usually have more tests, the lower level ones, you have more of them and you have fewer of the others. Whether that applies to monitoring, I think it does in a sense, because, I mean, in the end, I mean, it depends how you count alerts, right? If you are monitoring individual servers, each alert, I mean, it's going to be a ton of alerts. But even then, like, for instance, synthetics, which are a very powerful tool, I would use them to cover core flows. Like, I wouldn't really try to cover every single interaction there, but more like these are the core flows that I really want to ensure that work. And so there shouldn't be that many of them, right? Whereas for infrastructure, I would say that there's, especially if you are using a lot of, I don't know, like cloud infrastructure, there are a ton of moving pieces. So I definitely think that it should be like, I mean, I wouldn't say a rule, but I would say, like, I would tend to expect more lower level alerts to be present than higher level ones. Okay, is there any other more questions? I don't see any raised hands. All right, then that should be it. Thanks a lot for your attention.